And welcome back to my channel. Today in this video we are going to discuss the solutions of exercise 1C from Selina Concise Mathematics class 9 ICSE. And in this topic we are going to have surds and rationalizing factors. So surds are basically if x is a positive rational numbers and n is a positive integer such that x to the power 1 by n is irrational. So it cannot be this number. If you have, let's say, 4 square root of 4 or second root of 4, this is 2, which is not an irrational number, then it would not be a surd. Otherwise it is always going to be a surd, or we call it sometimes as radicals. And we talk about the rationalizing factors. So a irrational number which makes an irrational number rational is called rationalizing factor. For example, if we have root 2 and we multiply by root 2, then it will make it as 2, which is rational. So root 2 is the rationalizing factor for this root 2. Similarly, one more type like 3 minus root 2 is there, and if we multiply by something to make it rational, then we have only one irrational number, let's say 3 plus root 2. If we multiply by this, we will use the identity a square minus b square, we will get 9 minus root 2 square, that is 2, it would make it 7, which is rational. So 3 plus root 2 is the rationalizing factor for 3 minus root 2. It's basically the same numbers, only the sign is different. And if it is monomial, means only single term, which makes it irrational, you multiply by the same number, means rationalizing factor would be the same irrational number. So let's discuss the exercise 1C. Question number 1. State with reason which of the following are surds and which are not surd. So surd, we know that in the nth root there should be some positive rational number which makes it irrational, then only it is going to be a surd. So 180, in order to check whether it is rational or not, we have to do the prime factorization, and 180 prime factorization is 2 into 2, 3 into 3 into 5. So 2 and 3 will come out, but root 5 is there, which is of course irrational number, and 5 is a positive rational number, that's why it is going to be a surd. Similarly for 27 can be written as 3 into 3 into 3, which will not come out of the fourth root, so it is going to be irrational number, and this is positive integer for positive rational number, that's why it is going to be a surd. Similarly for third 128, we can do the prime factorization, we will get 2 into 2 into 2 into 2 5 times, and then 2 more times 7 times. So this 5 pair of 2 will come out once, and 4 is still there, which is again a rational number, and hence it is going to be a surd. Next is 64, cube root of 64, 2 into 2 into 2, and again 2 into 2 into 2. So we have 2 pairs of 3, like 3 multiple of, we can say 2 as a pair of 3. So we can take it out and we will get 2 into 2, that is 4, which is rational and hence not a surd. For 25 into 40, alone they are irrational number and hence they are surd, but if there is a multiplication, we will do the prime factorization. 25 is 5 into 5 and 40 is 2 into 2 into 2 into 5, and when we will combine, we will get up 3 pair of 2 and 3 pair of 5, so it will come out because it's a cube root, and hence we will get 10, which is rational and hence not a surd. Similarly for minus 125 minus 3 times, it will come out, and which is rational, hence not surd. And here it is root pi, and pi is not a rational number, that's why, though it is positive, but it is not rational number, that's why it is going to be not a surd. And again this is 3 plus 2 root is positive, but again it is not a rational number, that's why this whole thing, this is a irrational number, means it is not rational, yeah, okay. If 3 plus 2 root 2 is not a rational number, that's why the square root of this would not be a surd. Now we need to find the lowest rationalizing factor. Lowest rationalizing factor, again rationalizing factor means a number, irrational number, by which we multiply to make it rational. So we always find the lowest rationalizing factor, and here we have 5 root 2. So 5 is a rational number, and if we simply multiply by root 2, it would be a rational, that's why this lowest rationalizing factor is root 2. Similarly for 24, we will factorize it prime factorization is the key in the rational and irrational numbers. So 2 into 2 into 2 into 3, so there is 2 pair of 2 which will come out and we will get root 6. So that is root 6 is the rationalizing factor, lowest. And rationalizing factor for root 5 minus 3 is simply root 5 and 3, but the sign would be different. Similarly for 7 minus root 7, that is going to be 7 root 7, but it is plus. And here root 80 and root 50, whenever we have a composite number, we need to do the prime factorization, and we can see 18 is 2 into 3 into 3, and 50 is 2 into 5 into 5, which will be 3 root 2 and 5 root 2. And now they are like terms, so we subtract it, we get minus, because 5 is bigger number, minus 2 root 2, and hence we only need to multiply by root 2 to make it rational. Rationalizing factor is root 2. Again root 5 and root 2 with minus, so it is rationalizing factor is going to be same, but only the sign would be different. It is minus, so it would be plus. And for rationalizing factor for root 13 plus 3 would be root 13 and 3, the sign is plus, so it would be minus. And here we can take 3 common, and this will become 3 times 5 minus root 2, and this 5 minus root 2 is an irrational number, so in order to make it rational we have to multiply by 5 and root 2, the sign would be only plus. So rationalizing factor is this. Similarly for this cannot be simplified more, so this rationalizing factor is same again, but the sign is minus. And the third part is to rationalize the denominators. So rationalize the denominator means we are going to find the rationalizing factor and we multiply. It's like 3 equals 6 by 2. So if we multiply anything in the numerator, we have to multiply in denominator as well. So 3 and 3 can be written as 3 by 1. If I am multiplying by 2 in the numerator, I have to multiply in the denominator as well. Then only we will get the equivalent fractions. So now if we have 3 over root 5 and we need to rationalize the denominator, it means we need to multiply by root 5 in the denominator to make it rational. And since we are multiplying by root 5 in denominator, we have to multiply in the numerator as well, and which will make it 3 root 5 in the numerator, and root 5 into root 5 is 5. And hence that is the rationalized form where denominator is rationalized. And 2 root 3 over root 5, we need to make rational, we need to rationalize the denominator, so only need to multiply by the denominator rationalizing factor, that is root 5 again. So we multiply, and in order to balance we have to multiply in the numerator as well, and numerator we got root 3 into root 5 root 15, and denominator it is 5. Similarly for third one, rationalizing the for rationalizing the denominator, we can see the denominator is root 3 minus root 2. So its rationalizing factor would be root 3 plus root 2. So we will multiply this whole thing by root 3 plus root 2 in the numerator and denominator both, just to balance it, so that it would remain 1 over root 3 minus root 2. And now the numerator is 1 into this, that is root 3 plus root 2, and denominator become a minus b into a plus b, and that is going to be a square minus b square. That is what we have used here, and 2 square and square root got cancelled, and we got 3 and 2. 3 minus 2 is 1, so numerator no need to write 1. Denominator actually 3 by 1 we always write 3, so it's like root 3 plus root 2 over 1 is root 3 plus root 2. And here root 5 plus root 2, so rationalizing factor is root 5 minus root 2. We multiplied it here, we use this identity a plus b, a minus b as a square minus b square. We will get the same thing, we can cancel these two and we will get the answer root 5 minus root 2. And here also we only need to focus on the rationalizing factor of the denominator, that is of course 2 minus root 3 in this case, because it was 2 plus root 3, and just to multiply in numerator and denominator by both, we got numerator as this identity a square minus b square, but in denominator we got a square minus b square, but in numerator we got a minus b whole square, because we are multiplying the same number twice, so it becomes square. And then we will use the identity a square plus b square minus 2 times ab, and a square means 2 square is 4, b means root 3 square is 3, and minus 2 times 2, and root 3 is 4 root 3, which will give 7 minus 4 root 3, because denominator is 1, so no need to write the denominator 1. Similarly for this, we are going to again get a plus b whole square, and denominator is a minus b a plus b, so we will calculate it again in the same way. For seventh part, again we are getting the same thing. In order to rationalize the denominator, the rationalizing factor is root 3 minus root 2. We calculate it and we will get this answer. And for next part, root 6 root 5, it is plus, so the rationalizing factor is root 6 minus root 5. We multiply, we will get our answer easily. And now for this ninth part, rationalizing factor is of course 2 root 5 plus 3 root 2, because it's a minus here, and we have multiplied, and again we got the same thing. The only difficulty in this type of questions they can come is like just to simplify it, and we can see it is same into same number, so a plus b whole square, and that is a square 2 root 5 square plus b square, that is 3 root 2 square, plus 2 times first function first term and second term, and 2 root 5 whole square is 2 2s are 4, root 5 into 5 is root 5 into root 5 is 5, so 5 4s are 20 we got, and 3 3s are 9 into root 2 is 2, so 9 2s are 18. Similarly root 5 into root 2 is 10, and 2 2s are 4, 3s are 12, so we got this, and we will simplify. We will get this as 38 plus 12 root 10 over 20 minus 18, that is 2 times, I have taken 2 common from here numerator, and we got 19 plus 6 root 10, and then these two got cancelled, and we got only 19 plus 6 root 10. Now the next question, fourth one, find the values of a and b in each of the following. So we need to compare these two. If we need to compare, it means it has to be in the form of this, otherwise we cannot compare. So we can see the denominator is not rationalized, so in this type of question it's not necessary to be asked like you need to do the rationalize the denominator. We have to do on our own. So rationalizing factor for 2 minus root 3 is 2 plus root 3, so we will multiply by numerator and denominator with the same thing. Numerator will get 2 plus root 3 square, which is 2 square, that is 4, root 3 square, that is 3, and 2 times 2 into root 3 is 4 root 3, and denominator is of course a square minus b square, that is 4 minus 3, 1, and hence we got 7 plus 4 root 3. After solving this, we will get 7 plus 4 root 3, and when we will compare, we will get 7 as the a, and root 3 term is b, so it would be 4. So a is 7 and b is 4. Similarly for the second part, root 7 minus 2 over root 7 plus 2 as this. So we need to convert this left hand side in this form in the numerator only, so that we can compare. And in order to rationalize the denominator, we have to get the rationalizing factor of root 7 plus 2, which is root 7 minus 2. So we multiply in numerator and denominator. In numerator we got root 7 minus 2 whole square, in denominator we got a square minus b square. So we will simplify this, and we got 11 by 3 minus 4 by 3 root 7, and this I have written with the root 7 first, so minus 4 by 3 root 7 plus 11 by 3. Now if we compare, we will get a value as minus 4 by 3 and b value as 11 by 3. Similarly for the third part and fourth part also, because in these questions we only have to do the rationalization. And here is the fifth question. Simplify these fractions and the sum and difference. So in these type of question, one type is when we have denominator as the rationalizing factor of each other. So here we can see the 2 root 3 plus 1 and 2 root 3 minus 1 are the rationalizing factor of each other. So in this case we are going to simply do it like normal fraction. Let's say 22 by 7 plus 5 by 3, we do it 7 into 3, and then 22 into 3 plus 5 into 7. So in the same way we will do it here, and the reason behind is because the denominator we have, if we have rationalizing factor of each other, so if we multiply, we will get the denominator as a plus b and a minus b, which will make it as a square minus b square, and that can be simplified very easily. So we multiply the denominator as it is, and 22 into this by cross multiplication, 22 times 2 root 3 minus 1, and 17 times 2 root 3 plus 1 here. And if we simplify, 22 into 2 44 root 3, 22 into 1 is 22, and 17 into 2 34 root 3, and 17 into 1 is 17, and we simplified 44 and 34 is 78, and minus 22 plus 17 is minus 5 upon 11, because denominator is 2 root 3 square minus 1 square. 2 root 3 square means 2 2s are 4, root 3 into root 3 is 3, so 4 3s are 12 and minus 1 is 1, 11. Similarly, for the second part, again we can see the denominator are the rationalizing factor of each other. So if they are rationalizing factor of each other, what we are going to do, we are going to simply use this normal method to of like calculation sum or difference of the two rational numbers. So the denominator, of course, we will multiply these two, and we got root 6 square, that is 6, root 2 square, that is 2, and 6 minus 2 is 4, and numerator become root 2 into this whole thing, that is root 2 into root 6 plus root 2, minus root 3 times this whole thing, that is root 6 minus root 2, and if we multiply we will get root 12 plus 2, because root 2 into root 2 is 2, and root 6 is root 18 minus plus, then it is going to be root 3 into root 2, that is root 6. So now we can see it is 2 times 2 plus root 6. I managed them like in the same order, 2 plus root 6 plus root 12 minus root 18 over 4, and now still we can see that 12 is 4 times 3. So if we have the square root, 4 will come out, that is with 2, and root 3 is there. Similarly, 18 is 2 into 9, so if it is square root, so 9 will come out as a 3, so 3 root 2, and finally we got it as 2 minus 3 root 2 plus 2 root 3 and plus root 6 in the order of the in the increasing order of of a root. Now sixth question, if x is root 5 minus 2 over root 5 plus 2 and y is root 5 plus 2 over root 5 minus 2, we need to find x square, y square, xy, and x square plus y square plus xy. So in these type of question, what we are going to do, first of all, if it is not rationalized, so we have to rationalize from our side first of all, because it was root 5 minus 2 over root 5 plus 2. So if we rationalize, we will multiply numerator and denominator by the rationalizing factor of the denominator. So we got root 5 minus 2 in the numerator and denominator, and then it is going to be root 5 minus 2 whole square, that is root 5 square is 5, 2 square is 4, minus 2 times AB, that is 2 2 is 4 and root 5 over 5 minus 4, because root 5 square is 5 and 2 square is 4, and that is going to be 1. So numerator become 5 plus 4 9, 9 minus 4 root 5. And now if we have this in a like a simple numerator only, then we can simply calculate x square by taking the square of this, that is a minus b whole square. So a square b square minus 2 times a b, and we can simplify. 9 square is 81, 4 root 5 is 4 4 is 16 into root 5 is 5, root 5 square is 5, so 16 5 is 80, and we got 161 minus 72 root 5. And now for the second part we have y square. So first of all we have to simplify y. Y is root 5 plus 2 over root 5 minus 2. So we will multiply and divide by the rationalizing factor of denominator, that is of course root 5 plus 2. So if you multiply, numerator is root 5 plus 2 whole square, which is going to be root 5 square, that is 5, 2 square 2, and 2 times 2 into root 5 is 4 root 5, and denominator is still 5 minus 4, that is 1. So we got it as 9 plus 4 root 5. So y square would be in the same case, the square, and this is the identity, and we got 81, 80, 72 root 5, and then we got this. And now it would be easier to solve the third part, because once we have x and y in this simplified form, then we can see it is going to be 1. Otherwise also, if we want to use directly xy value, then we can see that x is root 5 minus 2 upon root 5 plus 2 and multiplied by the reciprocal of it. So we know that it is going to be root 5 minus 2. This whole thing got cancelled and we got 1. And from here also we can see 9 minus 4 root 5, 9 plus 4 root 5. So a square minus b square, 9 square is 81 and 4 root 5 square is 80. 81 minus 80 is 1. And the last one, fourth part, x square plus y square plus xy. It is 161 minus this, because we have calculated 161 minus 72 root 5 as a x square, 161 plus 72 root 5 as y square, and xy as 1. So we can simplify, we'll get this as 323. So that's it for this video. We will discuss the last few questions in the next video.